A function generator is an instrument that lets you produce a voltage that varies with time. So what I have here is a function generator, and I have hooked it up with a coaxial cable to an oscilloscope so that I can actually show you the shape of the output. So I'll just quickly turn that on. The oscilloscope here actually shows me voltage versus time. So I'm seeing here that there's a sine wave on the oscilloscope screen. It means that the function generator is producing a sine wave. So on this instrument, the way that I toggle whether there's an output is I use the button here that just says output. When I have this turned on, then it's generating a signal. I then can control the signal using these buttons down here. So for instance, if I press function, then I choose the different types of voltage waveform that it can generate. So for example, square wave, which you can see here. A triangle wave looks like that. It can also generate random noise. And an arb means arbitrary, so you can actually program in a specific waveform if you want a certain shape. I'll just put it back to sine wave for now. If I would like to change the frequency, I would press frequency, and then I can just type it in. So if I wanted, say, 1 kilohertz, I'd press 1, and then the button for kilohertz down here. And so now I have a 1 kilohertz sine wave. I can also use the arrow keys here to select one of the digits and then kind of scroll through and adjust that in order to just dial in a particular value. For amplitude, again, I would press type the number, and then I want voltage peak to peak. So I'll press that. So this gives me 4 volts peak to peak. Now I see here on my oscilloscope screen I actually have 2.1 as the maximum and minus 2.1 as the minimum, so it's actually slightly higher than what I have selected here, and so that's basically because there will be some tolerance or some kind of imprecision in this system, and so the value that I measure on the oscilloscope is not quite the same thing as what it says here on the screen. I would probably trust the oscilloscope more than the function generator in this particular case. The offset refers to the average value. So for instance, if I adjust the offset, then you see that I'm kind of moving this voltage up and down as I scroll through those values. Again, of course, I can just type them in on the keypad and then press volts here to actually lock that in. So for instance, a negative 0.5 volts, and I just lock that in, 0 volts back to the middle. Now, one thing to be aware of with this particular instrument is there's obviously 2 coaxial plugs here for the output. So most function generators will have 2 pins that you can use, and you have to be careful about which one you select. So one here is labeled as sync, and one here is labeled as main. So if I actually plug into to this sync pin, then I see this kind of funny looking square wave. Let's just adjust that so we can see it more clearly. So I have a square wave that goes from 5 volts to basically 0. And it's not at all what I was asking for, right? So here I have configured a sine wave, but what I actually see is a square wave, and the amplitude is different as well. And so the thing to understand, the purpose of this sync output is that the rising edge of this sync pulse corresponds to the beginning of the waveform that is being generated. So I could use that to trigger some other instruments. If I have a sophisticated test bench, if I want to run multiple different things and I want the timing to be synchronized, then this here is now a timing reference that I can use to trigger other devices from. So if you actually don't care about timing and you're not trying to synchronize multiple instruments, then you need to make sure that you're choosing the correct output, which is the one that's labeled main here on this instrument. Another thing to be aware of is that this thing has 2 different modes corresponding to what's called high impedance output or 50 ohm output. So the difference here is that if I am driving a high impedance or basically a high resistance load, such as an oscilloscope, then I should choose that setting in order to get this voltage to be correct. So right now I see 4 volts peak to peak, and I actually measure 4 volts here peak to peak approximately on my oscilloscope. But if I change this to 50 ohms, this number will be wrong. So let me show you. the way to get this, the shift key, shift is blue, this little blue text above, you're supposed to recognize that this blue is related, so I press shift output. It very briefly flashes here on this amplitude to say 50 ohm or 50 OH. I'll press that again so you can see. So I'll press it, watch here on amplitude. You'll see H1 or HI, high impedance, 50 ohm. High impedance, 50 ohm. And the difference is the scaling value that's used here for this voltage, because right now this is labeled as 2 volts peak to peak, which is completely wrong, because I can see here this voltage is clearly 4.4 volts peak to peak. 4.4, not 2. Very, very far off. But if I change back to high impedance, HI, I see 4 volts peak to peak. That's close to the 4 volts peak to peak that I see here. So that's a bit more realistic. So it's really important that you recognize these two different output modes. I think it's actually a design flaw of this function generator that the scaling is not shown on the screen. The only way to see it is to kind of change the mode with this functionality that's kind of hidden, right? You have to press shift and then output to actually see that. So particularly in a university setting where someone might have been fiddling with the instruments before you, it's really important that you go through and check these settings to know which one you actually are intending to use. So if most of the time in this class you're going to want this high impedance mode because you'll be driving this into a circuit with a resistance that is greater than 50 ohms. Now I've got here a coax cable. Often you would want to be connecting this up to a breadboard circuit, and so you would use a cable like this one where I have coax on one end and some alligator clips here, so I can connect this up to the rest of my circuit in order to actually use this. So there we go. That's how you use a function generator.